Hello and welcome to this short video, where I will try to draw my research topic in less than 5 minutes. First of all, my name is Jürgen Hackel and I'm a PhD student at the Infrastructure Management Group of ETH Zurich. My thesis has the melodic title Stochastic Spatial Temporal Network Modeling for Infrastructure Systems. This title already indicates that I'm dealing with probabilities, space and time, networks, and of course infrastructure. Before I will explain my work a little bit more in detail, allow me to summarize why transportation infrastructure is important to us. In our everyday life, we are using infrastructure systems such as the electronic power grid, railway or road networks without thinking too much about them. But these infrastructure networks are the backbone of our modern society and allows us, for instance, to transport products and goods, information, human beings, or all kinds of natural resources to almost every place in the world. In order to fulfill all our requirements, infrastructure networks have become very complex. For instance, we have to deal with different levels of hierarchies inside a single network. When we are looking at road networks, those hierarchies might be motorways, primary roads, or secondary roads, and users have different expectations for each type. Also, in our modern world, we can no longer consider pure single network at its own, because there might be interdependencies with other networks. One good example is the railway, which relies on a power grid. And this complexity turned out to be a huge issue for people who are working with such infrastructure networks, because the failure of one tiny component in the network can have a dramatic impact on the overall network performance. These so-called cascading effects are responsible for blackouts or traffic jams. Often, the failure are caused by external events. In my thesis, I will limit myself only on natural hazards like earthquakes, floods, and mass movements. In order to estimate such network-related risks, models for the network, users, and external events have to be set up. In common practice, these models are mainly deterministic, computational intense, only suitable for small problems, and/or need a huge amount of data. This makes the risk assessment to a really challenging task. Here is the point where my thesis becomes interesting. I'm going to develop a mathematical model which allows us to describe the network-related risk for transportation infrastructure systems in a stochastic framework without the need of endless data. This work contains the development of 4 major parts. Firstly, spatially embedded random networks for the description of the structure. Secondly, network rigging for the estimation of the demand. Thirdly, a spatial temporal random field model for the occurrence of hazard events. And finally, a loss model for the risk calculation. Because my work touches up on different fields of research, everyone is cordially invited to share his or her thoughts with me. This is now the end of drawing my research. Thank you very much.